Okay. Am I audible? Okay, perfect. Yeah. So let's begin with where we left off yesterday. Okay. Oh, yeah. Let's increase the font and start. Okay. So the question is, run the appropriate command to check the current version of the API server, controller manager, scheduler, kube proxy, core, DNS, etc. Okay. Okay. The output should look similar to. Okay. So it looks like KubeADM was used to deploy this cluster. We have a hint. Let's try it out. Okay. Version is it KubeADM version? Is that what we want? Doesn't seem like it. Keep count version. Let's see if we can do anything else. Minus YAML. My bad. Current document. Let's check the docs. There should be some sort of describe. Create a cluster. No. Let's see. Upgrade join token. Yes. I'm sorry for that. To print the KubeADM version, manage kube config file. Okay. Yeah. Do we have anything over here? Not help. Come on. Oh, I lost my keyboard again. In the meanwhile, no. Okay. Yeah. Back. I thought I solved that problem, but I guess not. With the help, upgrade to new version. Reset, join, init help, without any command. Version. Config. Print. Oh, my bad. Come on. Oh yeah. I don't think this is it. Okay. See the solution. Upgrade plan. Okay. Current target version. Oh yeah, the target. So this is how we should have figured it out. Run the command to upgrade the control plane components. Determine why you received the following message. Specified version is higher than the QA version. Upgrade QADM first. Okay, so we need to upgrade QADM. So let's see. Upgrade. Oh. Are outlined in the older version. Please refer. Okay. We get the plan. How do we upgrade QADM? Yeah. Is it? Are we allowed sudo? Okay. So that is how we'll upgrade QADM first. Grade cube install QADM. Come on. Okay, let me just try something to fix this issue. Let's see. Hardware. Remove USB device, USB port. That's different. That's 5. No. Okay. We have our mouse back. I hope this doesn't cause issues. Let's see. QADM. So we upgraded it to 1.30.4. Okay. I guess. Oh, okay. Now let's try upgrade apply. You can look at this config file. Okay, I'm sure you want to proceed. We won, but it's asking for. Okay, QADM version. Yeah. So detected that sandbox image read. Also, container runtime is inconsistent with that used by Kubernetes use registry. Okay, this can take up to 5 minutes. Okay. Meanwhile, we can see what else do we need to do for upgrade. So we do a plan first. We do apply. Upgrade your Kubernetes cluster to the specified version. Upgrade version. Oh, do not change any changes. This would be performed. Oh, not required. Wait, node. Oh, no, okay. Program executes the following. Saves. Build a control plane instance deployed on this node, if any. Okay. For a node and a cluster. And what is just upgrade to? Oh, complete cluster. Okay. This seems to be going to take a lot of time. Let me check that. In the meanwhile, how am I sounding on stream? TV/noob hacker with double K's. Yeah. Do we need a mic test? Oh, that's pretty good. Yep. Okay. What do we do? In the meanwhile, let's go here and check out some stuff. Okay. Oh, this is. Are we in this one? Oh no, this is the other one. Okay. Areas. How do we have examples? Yeah, CKA. We have to do these also. Okay, we're done here. Amazing. Yeah. Let's just check again. Great plan. Yes. And check you realize that you can't upgrade past the current version of Kubernetes. And the appropriate commands to resolve this problem and get your cluster to. Okay, yeah, we did that. Okay, what is this? Get the version of Kubernetes. Okay, didn't we get it? Okay, yeah, it was jumbled up when we did just this. I think we did minus away ammo. Okay, yeah, but this is pretty. And upgrade, so the apt install. Okay, so we should have given the version number also. Okay, run the Kubernetes of your plan again and proceed with the upgrade with upgrading the control plane too. Yeah, we did that, right? Okay. Oh, that was easy. Create service account for a pod. Okay. Setting up. Let's increase the font. Oh yeah. Let's increase this to 120, 130. Yeah. So create a new service account named Secure SA. Let's copy this. And the default namespace that will not automatically mount the service account token. Okay. Okay. Create service account. This. search for pods. Yes. Before we use default. So, access API server. No. Advanced service. Okay. Can I get this? Let's open up our commands. Commands. Ooh, easy. Oh, I have to do something about this keyboard. But that's fine for the time being. It's a keyboard issue, I guess. Once again, let me just try something else. Okay, this is working for now. I hope this doesn't give us any issues. We have our mouse also. Yeah, we need this. kubectl commands right here. Create service account. No, we could do that. Let's see if we can allow us interpretation. Apparently not. Okay, then we'll just do a try run. Service account. Try run equals client minus o YAML. For the CKA exam, yeah, we can do that. Just remember the question number, save it to that. So we can just change this, and we don't need this. All we require is right here. Okay, it just gave some metadata. You can also opt out of automating for a particular pod. Okay. Yeah, we just need this. Okay, apply minus one.yaml unknown field metadata automat. Shouldn't be in metadata, it should be in spec, right? Oh no, it is a whole field in itself. Okay. Okay. Ah, I don't like that. Copy. Yeah. Oh, it executes. Yeah, we have an essay. Next. Create a pod that uses this. Make sure the token is not exposed to the pod. Verify that the service account token is not mounted to the pod. Okay. So that's how we create the pod. One pod dot, yeah. This account is CKA minus the pod. My pod is invalid. Oh, just run my pod image engine try run client. Oh yeah, yeah. No, one pod dot yeah. Let's just remove the stuff. Oh, the pod specs. That makes sense. And we apply. How verify that the service token is not mounted to the pod? How do we verify that? Service account token. Manually clean up. Use more than one. Volume projection. Let's see. I can check service account token. Oh, can we describe pod? My pod? Can I just grab some token or something? Okay. Okay, describe service account. What gotta say? No token. Okay. Let's see. One pod. Let's copy that. One pod. YAML. Nano 1A. What the hell? Nano 1A. And let's try to and we change the name. Token pod. Okay, apply minus F1A. Okay. Okay, describe SA. Here, okay. Not opens. Okay, describe pod 1A. Oh, sorry. Token pod. Do we have any tokens? Okay, so how do we check? Watch the pod image and pod. Automount. So this doesn't automount anyway, right? Okay. Secrets Kubernetes. No set file or directory. Okay. So it's mounted as a secret. Tains and tolerations. Okay, this is going to be fun. Run the command to list the tains applied to. Okay. That's cool, man. Come on, man. Yeah. Okay, get nodes. Okay, describe node 1. There is that, but I prefer dedicated special user, no schedule. Okay. Yes, keep going. Yeah, that's what we did. Change. But don't do this because of when there are, like, for example, multiple, it'll just show one. So for example, if we do for labels, okay, so yeah. So if we do, you'll just get one label, whereas we know that it has multiple labels. So that would be incomplete information. That's why I always just go to where it is. Dedicated special user, no schedule. Okay, yeah. Next. View the file in your home directory name. Okay, apply the correct toleration to this pod manifest in order for it to successfully get scheduled to node 1. After modifying the pod.yaml, run to create the pod, then run the command to verify that the pod status is running. Aftermath. Oh, tains and tolerations. Let's zoom this in too. Yeah. Tains and tolerations, right? Yeah. This should be in the spec. Yeah, just like this. No, pod. Paste this. Okay. We know since there's only one. That's why I'm doing this. Yeah. Key is dedicated. Let's do this way. Where this will work. Okay, apply. Pod.yaml. Okay, get pods minus o wide. Sorry. Watch. And we have it running. So this is one way to do it. But it's better if we be more specific. So we can do an operator equals. We have any operator equal. Yeah. And then we give values. So operator equal and value. Would be special user. Okay, Notion. So now delete pod nginx, sure. And when we apply again, we have it running. Okay, describe pod nginx. Tolerations. We've given a proper toleration. Solution. Give it a toleration. That is specific key value. Okay. The solution does not give the operator key, but I'm sure you're supposed to, like, given the documentation, I'll follow the documentation. I think we can get done with this one today. Backup etc. Okay. Let's do this. How to back up the Kubernetes cluster configuration by taking a snapshot of the etcd data store. Increase the font. Okay. Backing up an etcd cluster. Ooh. Yeah. India also requires a valid client certificate and key look. Yep. So do we have etcd utl? Yeah. Oh, we don't need. Can, but do we have it? Okay, we don't have it. So never mind. Just like Kubernetes API, the etcd data store requires authentication, which can be passed as a parameter to the etcd tool. Etc. Also requires environment variable, which is set to the version of the environment variable before you backup. Yeah, as they mentioned. We export this, backup, and pass in the certificate authority, the client or the server certificate, and the priority key. So let's see what certificates we have here. CD LS. So here, yeah, this is how you do it. So we just this. This. And yeah, this amd.txt, Ctrl+X. We have this here. We have exported that, so we can just take this part. And now endpoint. Let's find out what endpoint we have. Okay, we have. Okay. Where are we? Oh, in root. Got it. Let's snap. Go back. Yeah. We'll take it from the documentation. Come on. cat cd txt. So we need to get cd etc ls etc Kubernetes manifests kube API server. etcd. Okay, that is the server. So can use that. CA cert. We have CA cert. Certificate for trusted CA key file. We have the CA cert. We have the server certificate. The server key. Backup location. Okay. Yeah. Paste this command. Yeah, let's do one by one. The cert is a.crt. Okay, no autocomplete there. The cert is server.crt. The key file is server.key. Even this keyboard gave up on me. Okay, let's just wait. Like the state of a snapshot, write the output to a table using this command. Okay. Do we have it here? Of the etcd pod. Amazing. Yeah. So let's set that. Let's check that once. No. etc Kubernetes manifests etcd.yaml. Third file, key file, and CA cert, right? Trusted CA file. Yeah. That's another place we can look for it. Oh, and yeah. Server cert is given. Key file, server.key. Snapshot is /root/ snapshot save. Snapshot saved. /root. Okay. Check the status. Deprecated. But we don't have that, so this is what we gotta do. Okay. Next. Now that we have a valid snapshot, let's modify the cluster state in order to stimulate its disaster. Let's delete the kubeproxy daemon set kube system namespace. Okay. Okay. Yeah. So we don't have a kubeproxy anymore. Oh no, how do we get our kubeproxy daemon set back? Good thing we have a backup. Click next to restore our beloved kubeproxy daemon set from our snapshot backup. Okay. Restoring an empty city cluster. No, we can't. Snapshot restore. If data is the same folder as before, delete it and stop it. What is the data tree? Yeah. Same as before. Directory that will be created during the restore process. Okay. What does this say? You just create some directory. We use command to restore from a snapshot and we used it to flag. What do we have there? Var lib etc. Nothing. Yeah, nothing. In the same directory as the current etcd member. Okay, let's try. We'll try something else. Oh, sorry. We'll do it right here. And we need to update the manifest for etcd and tell it to get its data from the restore operation we just did. Okay, and we close. On the 76th line. Kubernetes API will be unavailable until the etcd pod is restarted. This may take up to 3 minutes. Let's see if the kubeproxy daemon set has been restored. Okay. So it's just the data directory where. So it's better if we do it like that. Control U. Yep. And we'll change the manifest files. etcd YAML. Yeah, where's the data? Yeah, okay. Yeah, we do restore. Oh, yeah. Just if you require it, you can do this. No? Isn't it -n? Line numbers -l. Okay. Yeah, you can do this to get line numbers. Pretty helpful sometimes. It said line number 26. So do we need to do it more? We can just search for this. Oh my god. So we can't search for it like that because the shortcut to search is Control W in Nano, which just kicks us out. We have a snapshot. Delete. Ooh. What? Okay, copy that. Yeah, delete. We don't have kubeproxy. Run this again. It's restored. Now let's just see cat rep. There are 3 instances, so we have to change all 3. I know we can do it with the set command that is given, but it's better to give it a look. Better to know where are we making these changes. Because in the exam, I know I won't be able to write that set command. Like I can, but I wouldn't want to. I wouldn't, like, a small mistake and I've changed stuff that I don't know how to restore. But there's one more. On path and path rate. So we have volume maps here. On path and one path. Host path rate. This one shouldn't matter. Let's see. I don't think that one should matter. Volume conf to use volume storage. Control F. This is the volume. Yeah, volume name. That runs one container part. That lasts for the life of that pod, even if the container terminates and restarts. Here is the configuration for the file path. Okay. This is inside the container. So this path is inside the container. Not path. But we don't need to change it here. Yep. Let's see. Yeah, let's take its time. A get pods minus A from all namespaces. Or we could put from just, but that's fine. Minus A minus watch. We can't get the pods. Okay. So we can use the actual watch command. This is the watch that is command in Linux. which will keep running the kgetpods -a command every 2 seconds. And this is the output we get. No resources found. Oh, is it because it's a... I guess it does not take aliases into account. No resources found. We have the restore, right? What do we do now? Oh, do we wait for 3 minutes? Or have I made a mistake? We know if I've made a mistake. If we just do this. This shouldn't be an issue. There's a failed connection. Okay. Let's wait for this some time. Okay. If this works. Oh. I don't know if I want it to work. Oh, this works. Was my understanding wrong? When you do this, mount path rate. Okay. So volume etcd data, which is here, and I'm mounting it. volume etcd. Okay. Because we did this, we don't need to change this either. Uh-oh. Control X, no. So here you're looking in within the container. etcd is looking for data in this directory, and then here volume mounts, we gave just etcd. Yeah, we were looking in etcd restore, but there was no such path within the container. So what we're doing here right now is, from the host, we're taking this directory and we're copying it in this, and here the etcd command will look for that data directory here. Now this should work. Okay. Um, yeah. Now this should be working. So these are some not very difficult questions. You can like these are straightforward. This, but I don't expect the questions in the exams to be this easy. For that, you get access to this. When you book the exam, you get access to the simulator. So for CKA, we have 25 scenarios, so 25 questions, 120 minutes, 36 hours of cluster. Plus 5 extra. Oh, okay. You get 5 extra. The session, you will get access to the detailed solutions. Nice. After our CKA exam, we will be practicing for the CKS. Let's see if we're done here. Oh, amazing. Perfect. So that is how you restore from an etcd backup. My etcd snapshot. Create a new user in Kubernetes. See. User. In this scenario, we'll learn to add a new user and assign them permissions via RBAC in Kubernetes. See if you authenticating user namespaces using RBAC authorization. I don't know if you can go in discussions. Yeah. Role-based access in Kubernetes is used to permit actions being performed by users or service accounts on Kubernetes API resources. There are no deny rules in RBAC, so you must be careful to set actions that are absolutely necessary for that user or service account. Okay. Roles are created in Kubernetes to assign the access to Kubernetes resource in a given namespace. Role bindings are created with a namespace and attached to roles in order to assign that resource's permission to the service account or user. Cluster roles and cluster bindings work in the same way, but across all namespaces, cluster-wide. Okay. In order to create a role and role binding in a namespace, we have to create the namespace by using the command. Okay. Now let's create the role that will allow our new user to get and list pods in the web namespace. Okay. So we are creating this role within the namespace web, and the role pod reader will be allowed to get and list pods. Okay. We created the role. Now that we have created a role, let's assign this role to our new user named Carlton. Right. Carlton. So we make a role binding, pod reader binding, role user Carlton. Okay. We can't get users. It usually is a file. etc Kubernetes manifests API server. Yeah. Service account TLS. You pass it as an argument. Group client certificate. Proxy request group headers. Request header username. Service account. Service account. It is authentication done. Scheduler. Is that an ETC by any chance? shouldn't be. Authenticate. Token file. User impersonate. User set Kubernetes. Okay. A file. A user store with keys on. In this regard, it does not have objects be added to a cluster through an API, even though a normal user cannot be added in use. Okay, let's just read this. All Kubernetes clusters have two categories of users: service accounts managed by Kubernetes and normal users. It is assumed that a cluster independent service manages normal users in the following ways: an administrator distributing private keys, a user store like Keystone or Google accounts, a file with list of usernames and passwords. In this regard, Kubernetes does not have objects which represent normal user accounts. Normal users cannot be added to a cluster through an API call. Even though a normal user cannot be added by an API call, any user that presents a valid certificate signed by the cluster's key authority is considered authenticated. In this configuration, Kubernetes determines the username from the common name field in the subject. Okay, so if it gets the right certificate, it'll extract the name from it and be like, okay, yeah, this is a user. So can I just give any name? Okay, I can give any name. It doesn't know which user. It'll just check when performing actions through that user. Delete. Role. Finding. Okay, so we have this now. Use a cartoon here. Okay, get role bindings in the namespace. Wait. See. Okay. Delete role bindings. Yeah. Okay. Yeah. Oh, I didn't know that. Can we give comma for that? Wow. Okay. So we have a role, pod reader, and we have a role binding. What next? Let's create a pod in the name web namespace so our new user has something to look at. Okay. Since Kubernetes does not have a user resource, all that's required is a client certificate and a key with the common name to match the user's name. In our case, when we created the role binding, we assigned it to the user Carlton, so that user will assume the permissions from the role for that resource. As long as the common name is and the key is Carlton, you will be able to use this to access the Kubernetes API. To create a private key, we use the OpenSSL command line tool. We'll use 204-bit encryption and we'll name it Carlton. Okay, we make a private key. Okay, let's create a certificate signing request for the Kubernetes API using a private key and insert the common name and output that to a file named Carlton. So This I learned today itself, that API server client request. This one doesn't have it. Doesn't has. Yes, servers, kubelet client, certificate, request header, service account issuer, key file. This also. So you can also give certificate sign, like automate certificate signing requests here. Let's see. API server. API server. Certificate signing requests. Yes. Process. Okay. I'll have to read upon it more, I guess. Open SSL request, new certificate, subject CN. We have the CSR. Okay, suppose to. Now that we have a CSR, we can submit it to the Kubernetes API for approval. Let's store the value of CSR in an environment variable named request. What is the difference? I guess it's wrap. Come on. Help. Wrap. Yep. Default 76. Okay. So we can do this. Then we can create a YAML manifest and submit. Certificate signing request and output the result. Group system that wait certificates requesting certificate sign class. Yeah. Oh, we're plain automated. Certificate for create a submitted. This is where you come. This is where you get it from. Back request. Okay, this is where you put that. Your base 64 encoded request. Signer name. How do we know this? Oh, it's a default, I guess. Expiration. That's when the certificate will expire. Usage. Client out. Okay. Have to explain anything? Users has to be client out. Could be made long. Oh, request is base 64. They've done it the smarter way. Yeah, I have the Carlton one. Let's assume that the role we set for unusable. Do this. Approved, issued. It was pending first. See here, it was pending. Now it's approved. The output of the command should now show approved issue. We can extract the client certificate from the CSR command, decode it, and save it to a file name column. Okay. We get a signed okay, describe CSR Carlton certificate sign request. This request. Like what? Signed certificate. We don't want this, huh? Status. God. Name spec group system request. Signer name. See what this gives us. I guess describe doesn't give it completely. Get CSR. Carlton. Oh, yeah, we have the certificate. And that's the request. Okay. So we saved it. You can remove the embedded certs and they will remain pointers to the key. And embed certs. Credential. Carlton. Find key. Private key. The certificate. Yes. Okay. I'm just trying to wrap my head around what's happening. So we are setting the credentials. We're giving the private key. Config view. We say user. With this client certificate data and client key data. Client certificate is to prove who they are, and client key is to make sure the data you're getting from Kubernetes API is from the API server that you is from the correct API server and not some malicious server that is pretending to be your API server. So how would that work? So on when we browse the internet, we get certificate from the website proving that we are going to the right website, that we are communicating with the right website. So the certificate, whoever gives the certificate is trying to prove their identity. With your client key, you can, that's a private key. You can decrypt data that has been encrypted with your public key. Okay, so your certificate has your public key, which is vouched for by the CA certificate authority. So your certificate basically holds your public key, which has the stamp of approval from the certificate authority, and you provide this public key. Right? Yeah, certificates are to prove the authenticity of public keys. So you provide this public key to the API server, and yeah, the server uses this public key to encrypt data and send it to you. That is decrypted by a private key. And similarly, Oh, Control R doesn't sometimes work. I can do this. Similarly, the API server has a certificate of the CA to check everything. Kubelet client certificate. Kubelet client key. If I'm not wrong, this is the certificate and key to communicate with the kubelet client. Oh god, I'm so confused. There's so many things going on in Kubernetes. But okay. Yeah. The output of now shows Carlton as one of the users. Next we'll set and use the context in which Kubit Cartel uses to access the Kubernetes API. But I thought we could do this right. Can I ask Carlton get pods? No, in namespace web. Yes. Why are we doing all this? I think we create a new car. And we have a list also. Before plugin name. We don't have a list, right? Okay. But works here? No. Okay. That particular rule is bound to that user. How long has it been? 1 hour 23 minutes. I was hoping to get done with the whole thing today. How much did we do? Oh my god. Oh, this was create a new user. That is why. Apply node affinity, scheduling a part to a specific node, upgrade kubelet logging in Kubernetes. Config map. These should be easier. Okay, let's see what does these. We have to get done with all these. All of these. Okay. Alright. Yeah. This one has a lot many. Okay. So we'll continue tomorrow. The create user was actually all of them. Upgrading, create service account for a pod. This was new. Background BTCD. even though not new for me, but it was, you have to follow all the steps properly. That's important. And this one was pretty difficult. Open SSL thing. Let me just check. Is it available? Create certificates manually. Yeah. That's the stuff. Generate a CA key. Okay, according to CA. Generator. Certificates. Okay, yeah, we create a certificate and then we create a certificate signing request. Which was certificate request. Here we have certificate signing requests. So how to issue a certificate for a user? We do this. We send this. We approve it like this. Okay, it was all from here. Okay. Keep cut and roll down. Create roll and roll back. This is what we did first. Add to, okay. We have all the steps here. Perfect. That's beautiful. You just need to know where in the documentation this stuff is. Nice. I'm glad I found searched for it. On that cheery note, let's end today's stream. Goodbye.